Okay, let's dive in. Does your face actually change when someone is watching you, even if you're just like watching a movie on the couch?
Or, here's another one, could something really simple, like changing the color of the wall behind you, totally fool an AI that's trying to read your emotions?
These sound like hypotheticals, but they're not, are they? They really cut to the core of how we express ourselves.
Exactly. And they shine a light on the surprising challenges technology faces in understanding something so basic to being human.
Absolutely. Welcome, everyone, to the Deep Dive. Today, we're exploring the really fascinating world of emotional expression.
We'll look at how we humans show feelings, all those subtle ways, sometimes without even realizing it.
And then we'll pivot to the other side of it, the unexpected and, frankly, kind of wild difficulties in teaching computers, AI, to understand those same signals.
Yeah, we've got insights from a couple of really interesting sources for this. One's a recent study, an experiment actually, looking at people watching movie clips.
Right, seeing if their faces and even their hand gestures changed if someone else was just sitting there in the room.
Precisely. And the second source is a big review paper looking at how AI tries to categorize facial expressions, the methods, the successes, but also some pretty startling weaknesses.
So our mission today is to unpack all of that. What do these studies tell us about, the complexities of our own emotions?
And what does the current state of AI emotion recognition reveal about the gap, maybe the chasm, between machine perception and human reality?
We're going to get into which parts of your face might react more when you have an audience.
And we'll explain why training AI to genuinely get emotion is proving so incredibly tricky.
Plus, you'll hear about some almost absurdly simple things that can throw these very sophisticated AI systems completely off track.
It really sets up this interesting contrast, doesn't it? The kind of effortless complexity of us and the brute force struggle of the machines trying to catch up.
So let's start with us, with humans. It feels kind of obvious, right? If you're watching something really funny or maybe super scary, you feel what you feel,
Yeah, the feeling's internal.
right? So
Yeah.
whether you're alone or your best friend is sitting right next to you, surely your face does the same thing.
That's what you'd think. It's a very common assumption that our expressions are just like direct readouts of our internal state.
But the research suggests otherwise.
It does, including the study we're looking at today, consistently shows there's a big social element. Just having someone else present, even passively, maybe reading a book nearby,
Mm-hmm.
it can subtly change how you express emotions. Sometimes not so subtly.
So wait, it's not just about making your expressions bigger if you want someone to notice.
Mhm.
This happens even if you're not consciously performing for them.
Exactly. That's what this study tested. They had people watch movie clips designed to make them feel amused or scared or just neutral. And they did this either completely alone or with someone they knew just sitting quietly in the same room. They recorded them with a webcam.
So they could analyze facial movements, hand movements, everything. What did they expect to find? Just bigger reactions overall when someone else was there.
That was sort of the baseline idea, yeah. The hypothesis was, well, expressions communicate, so if there's someone to communicate with, maybe you express more overall.
Makes sense. And is that what happened? Did people just, smile wider or gasp louder because someone else was in the room?
It wasn't quite that simple. What they found was more nuanced. Yes, there was an audience effect, definitely. But it wasn't the same across the board, not for all emotions, and crucially, not for all parts of the face.
Okay, now this is where it gets really interesting. How did the face react differently? What was the key finding there?
This is fascinating. The study found a really significant audience effect, but mainly on the lower part of the
The
face.
lower part, like the mouth area.
Exactly. Muscle movements around the cheeks, the mouth, the jaw. These were used more often, and often more intensely, when people were in that social condition compared to watching alone, especially during the emotional clips, the funny or scary ones.
Huh. So things like maybe opening your mouth wide in surprise or a bigger smile, or maybe even like clenching your jaw during a tense scene. That stuff gets amplified just by having someone nearby.
That's what the data suggests. Those lower facial movements seem much more responsive to the social context.
Okay, what about the upper face then? Eyes, eyebrows. We talk a lot about reading emotions in the eyes.
Right, you'd think that would be key for social signaling too. But interestingly, movements in the upper face showed less of a difference between the alone and social conditions.
Really?
Yeah. Their activity, things like eyebrow raises or eye widening, seemed less bothered by whether someone else was there or not.
That feels backwards somehow, doesn't it? Why would the lower face be more social?
Well, it might seem counterintuitive at first, but it kind of lines up with some theories, even some neurobiology. The thinking is that upper face movements, like widening your eyes when startled, might be linked to more automatic, maybe older evolutionary responses.
Like an involuntary signal, not
Yeah.
really meant for someone else.
Sort of like an involuntary cue about
Blech.
your state. Yeah. Less directly involved in deliberate social signaling. The lower face, though, especially the mouth,
Uh,
it's incredibly flexible. It can make so many different shapes, crucial for speech, obviously, but also for social signals like smiles, frowns, grimaces, you name it.
and those are really visible signals.
Highly visible, yes. And they seem to have evolved as prominent social signals. So maybe they're more easily modulated consciously or unconsciously when others are present.
So it's like a difference between an involuntary hint about how you feel versus a more tuned signal aimed even subtly outwards towards others.
That seems like a really plausible way to interpret it, yes. The lower face is where a lot of our explicit emotional communication happens, even if we don't always mean for it to.
That's a really cool distinction. Did the study look at anything besides the face? You mentioned gestures earlier.
Yes, and this is another really important piece of the puzzle. They didn't just focus on faces. They also analyzed hand gestures,
Okay.
which often get overlooked, right? So much emotion research is just face, maybe voice. But hands do a lot.
Yeah, I can definitely picture watching something intense and like covering my mouth or fiddling with my hands without even really thinking about it.
Exactly, those kinds of things. They track gestures like covering the mouth or eyes, touching the face, other hand-to-body movements.
But what did they find with the hands?
They found that these hand gestures were used more often during the emotional clips compared to the neutral ones, which makes sense.
Yeah.
But importantly, they also showed an audience effect.
No way. So just like the lower face, these hand movements, which feel really spontaneous, were also more likely to happen or be bigger if someone else was there.
That's what the evidence points to. Hand gestures seem to be another channel for expressing emotion that's sensitive to the social situation, maybe even more sensitive than some upper facial movements.
Wow. That really broadens the picture. It's not just about a static facial expression.
Not at all. It's dynamic, it's multimodal face, body, gestures, all potentially interacting and all tuned to some degree by who's around us.
It just underscores how complex our emotional displays really are. Effortlessly complex for us anyway.
It does, though it's really important we mention a limitation here, one the researchers themselves point out. The people in this study, they were pretty specific.
No, so
Mostly young white women university students in the UK.
the classic weird sample, Western, educated, industrialized, rich, democratic.
Exactly that. So while the findings are super interesting for this group, we have to be careful about saying this applies to everyone, everywhere. Different cultures, ages, backgrounds. We need more research.
Absolutely, good point. Okay, so summary on the human side. Our faces, especially the lower half, and our hands, seem to be more socially aware than we might think, changing how we express feelings based on who's around.
Even passively around.
Right. Now, let's completely switch gears. Let's look at the artificial side. How are computers trying to grapple with this incredibly nuanced, context-dependent human stuff?
Yeah, this is where that review paper on AI emotion recognition comes in. And well, teaching a machine to truly understand human emotion, it's a monumental challenge.
Because, as we just discussed, it's so complex for humans. Subjective, context, culture, social cues.
All of that. And the AI has none of that internal experience. It doesn't feel, it's just processing data, right? Images in this case.
So how did they even start trying to teach it? What were the early approaches?
Well, early AI often used a kind of pipeline. First step, find key facial features, like the corners of your mouth, the shape of your eyes, maybe the wrinkles in your brow.
Mapping them to those action units you hear about from psychologists like Paul Ekman.
Exactly, mapping muscle movements to those action units, or AUS. Or sometimes they'd extract specific landmark points, precise pixel locations of features.
Okay, so find the features, then what?
Then those features, the pattern of AUS active, or the geometry of the landmarks would be fed into a classifier. Basically, a program trained to link certain patterns of features to emotion labels like happy, sad, angry.
Got it. But technology moves fast. What's the state of the art now? I assume deep learning is involved.
Oh, absolutely. The field is pretty much dominated by deep learning now, especially things called convolutional neural networks, CNNs.
Right, those are the systems that have gotten so good at recognizing objects in pictures, identifying faces.
The very same. They're incredibly powerful because they learn directly from the raw image pixels. You don't have to tell them which features to look for. They figure out the relevant patterns themselves.
So naturally, people thought, Let's point these powerful CNNs at faces and see if they can learn emotions.
That was exactly the path. And, on many of the standard tests, the benchmark data sets,
Large collections of faces labeled with emotions.
yeah. On those data sets, these deep learning models achieved really impressive accuracy scores. It looked incredibly promising.
But I sense a but coming.
A big but. The review paper really highlights a critical, almost fundamental weakness in many of these approaches that just rely on raw pixels.
Okay, what's the catch? What's the problem hidden behind those high accuracy scores on the test?
The core issue is, well, when these models learn just from pixels, they can get very, very good at classifying the images based on patterns they find in the training data, but that doesn't mean they've actually learned the underlying concept of the emotion.
Okay. Meaning they might be latching onto things in the images that happen to correlate with emotion labels in the data set, but aren't actually part of the emotional expression itself.
Precisely. They can pick up on spurious correlations.
Give me an example. What kind of non-emotional thing could possibly confuse an AI about whether someone's happy or sad?
This is where it gets, frankly, a bit startling and maybe concerning. The review points out how sensitive these models can be to tiny, irrelevant changes in the picture, things that have absolutely zero to do with a person's feelings.
Like what?
Remember that hook at the start? Changing the background color?
You're not serious. The color of the wall behind someone can make the AI mess up reading their smile.
Research has shown exactly that. A simple change in background or even foreground color can cause accuracy to plummet for some standard deep learning methods.
That's wild. What else?
Other things too. Slight changes in lighting, a bit of image noise, or even partial occlusions like someone wearing sunglasses or a scarf, or even just their hand accidentally covering part of their face.
So the AI isn't learning this pattern of facial muscles means happy. It's learning something like smiling pixels plus bright lights plus this specific background often equals happy in my training data.
That's a great way to put it. And if you change one of those other elements, the lighting, the background, add sunglasses, the whole association breaks down for the AI, even if the human expression is identical.
Because it wasn't truly understanding the expression in the first place.
Exactly. It struggles massively to generalize beyond the specific, sometimes superficial patterns it saw during training. It makes them brittle, unreliable in the real world where conditions are never perfect. They're classifying pixels, not interpreting human meaning.
Does the kind of data they're trained on make this worse? Are they learning from real spontaneous expressions, like the ones in the movie study, or something else?
That's definitely another contributing factor. A lot of the big benchmark data sets used for training AI are made up of posed expressions, meaning data sets like, say, CK Plus or KDEF, where actors or volunteers were specifically told, show me happy, show me angry, usually in very controlled lab settings.
So perfect, maybe exaggerated versions of emotions.
Right. They're useful because they're clean, clearly labeled. But they don't capture the subtle, messy, spontaneous expressions we actually make day to day, or even the kind of semi-spontaneous ones people made watching those movies.
So the AI gets really good at recognizing the actor playing happy pose, but then struggles with genuine, in-the-moment happiness.
That's a significant part of the challenge. Now, there are data sets with more natural, in-the-wild expressions scraped from the internet, things like EffectNet or FER 2013, but they're often harder to label reliably, they're noisier.
So it's a trade-off.
Yep.
Clean but maybe unnatural versus realistic but messy.
Yeah. And relying too heavily on the pose stuff can definitely lead to AI that looks good on paper but fails when it encounters real human variability.
Okay, so these are pretty major vulnerabilities, getting fooled by background color, lighting, sunglasses, potentially learning from artificial poses. Are researchers finding ways around this? How do you make AI emotion recognition more robust?
Yes, thankfully, the review does point to several promising directions. One key idea is moving away from just feeding the AI raw pixels and, in a sense, going back to basics by focusing on specific facial features.
Like those action units or landmarks you mentioned earlier.
Exactly. Methods that analyze AUS, or the geometric relationships between facial landmarks, they tend to be much less bothered by irrelevant background changes or lighting shifts.
Because they're tracking the actual muscle movements or feature positions related to the expression.
Precisely. They're focusing on the parts of the image that are inherently relevant to emotion, rather than getting distracted by the overall pixel patterns. They become more invariant to those superficial changes.
What else looks promising?
Other techniques include things like attention mechanisms, trying to teach the AI to focus its processing power on the most important parts of the face, especially useful if maybe the mouth is covered but the eyes are visible.
Making the AI smarter about where to look.
Right. And then there's a really fascinating approach that's actually inspired by our own brains.
Oh, how so?
It draws inspiration from brain lateralization, the idea that the left and right hemispheres of our brains sometimes process information differently. One side might focus on details, the other on the bigger picture, the holistic view.
Applying that concept to AI.
Kind of. Creating models that process different aspects of the facial image simultaneously. Perhaps one path focusing on fine-grained features, another on the overall configuration. The hope is this makes them more robust against those simple attacks, like color changes or occlusions.
That's amazing. Designing AI inspired by human brain structure to help it understand human expression better.
It really underscores that just throwing more computing power or more data at the standard deep learning methods isn't necessarily solving the fundamental problem here, which is genuine understanding versus pattern matching.
So these more sophisticated approaches, feature-based, attention, biologically inspired, seem like the way forward.
They definitely show more promise for capturing the nuanced, dynamic reality of how we express emotions and being less easily fooled.
Okay, let's try and bring these two threads together then. We have the human research showing our expressions are subtle, they're multimodal, involving hands too, and they're sensitive to who's around us.
Right, that deep, complex, socially tuned system.
And then we have the AI review showing that even advanced systems are currently quite brittle, easily confused by irrelevant visual details, and might be learning from unrealistic data.
Yeah, operating on a much shallower level, really good at classifying specific image types, but not truly interpreting emotion in a human way.
So where does that leave us? What's the big picture here?
Well, it paints a pretty clear picture of this significant gap that still exists, doesn't it? Between the effortless complexity of human emotion and the current capabilities of AI trying to read it.
The AI is recognizing patterns, but it's not yet interpreting meaning in the way a person does.
Exactly. And that has potentially huge implications, especially as these AI emotion recognition tools are starting to be deployed more widely.
Absolutely critical implications. I mean, if a system can get confused because someone changed their shirt color or is wearing glasses, how reliable is that? How fair is that?
Especially when you think about the potential applications people are exploring.
Like using it in hiring,
Yeah.
to assess job candidates,
Hmm.
or trying to gauge customer reactions, or even, more controversially, in areas like security or law enforcement.
Can we really trust systems with these known vulnerabilities in such high-stakes situations? Systems that might be biased by unrepresentative training data or fooled by simple visual noise?
It seems like a massive risk.
It really underscores that this technology, while advancing, is still very much under development. The sheer complexity of human emotion means there's a very long road ahead. And relying on current systems without acknowledging these deep limitations could lead to significant misinterpretations, biases, and potential misuse.
Definitely requires extreme caution and much more robust development. So thinking back on our conversation, what really stands out to you? Is it that surprising finding about our faces reacting differently just because someone's nearby?
That's definitely striking, that subtle social tuning.
Or is it maybe the almost comical vulnerability of the AI, the idea that changing the background color could totally flummox a system trying to read your feelings?
Both are powerful takeaways, I think, because they perfectly illustrate that contrast we talked about, the deep, nuanced, almost unconscious sophistication of human social behavior.
Versus the current AI approach, which is powerful in its own way, pattern matching at scale, but still fundamentally missing that layer of genuine understanding. Miles away, really.
Miles.
It really makes you think, doesn't it?
Yeah.
Consider how these two worlds are going to intersect more and more. On one hand, you have the subtle, complex reality of how we actually express emotions tuned by context, shown through face and body.
And on the other, you have this still developing, sometimes surprisingly fragile AI trying to interpret those signals.
What happens when the technology that's supposed to understand our emotions fundamentally misses or misreads the very nuances that make those expressions human and meaningful in the first place? What are the consequences down the line? Something to definitely keep thinking about.